Alright guys, this video is going to go over some of the basic logarithm properties that we've talked about. So all the way from the beginning when we first introduced logs up to, we're going to talk about 5 properties plus an additional use. So the first one that we talked about was just the basic way that we can express logarithms and how they relate to exponential functions. So we can check out here, we've been working a little bit with exponential functions, and we know that it's an exponential function is some base raised to a power, and that's going to equal some other term here, in this case an x. So the way that we can deal with this is we have this form, the logarithmic form of this exponential function, and basically we're just going to kind of move some things around and express it in a different way. So these are two different ways of basically saying the same thing, and I've color coded so you can hopefully see where these things go. So we have this exponential function b to the y equals x, and we can transform that and change it into an equivalent expression, log base b of x equals y. So if you remember, a log is really just a different way to express the exponent. So this expression right here is just a different way of saying what the exponent is, and our exponent in this case is y. So we can turn this exponential function b to the y equals x into log base b. This is what's being raised to the power of x equals the exponent. So again, a log is just an exponent, very simply an exponent, a different way to express what that exponent is. How do we use this? Well, number one, we can go back and forth between forms, and sometimes that's useful in allowing us to figure out what we're trying to do. So we want to write each of these expressions in logarithmic form. So if I take this, again, here's our outline up here of how we go back and forth. This one is in exponential form, and so is this one. So we want to go from exponential to logarithmic. And the way that I write this is the log of our base, whatever's being raised to the power. So in this case, our base is 3. That's what's being raised to the power, log base 3 of 5. So this guy comes over here, and that's equal to the exponent. Well, what's the exponent in this case? It's x. So this is an equivalent expression to what we started with, just a different way to write it, and in particular, it's a way that we can write it in logarithmic form. Let's go over to number 2. We want to write this in logarithmic form and just express it in a different way. So we want to write it as a log. So we have a log base, whatever is being raised to the power, that's 9 being raised to that power. So we have log base 9 of this number over here is equal to whatever the exponent is. This logarithm is just an exponent, so the exponent in this particular case is x plus 4. So again, just an equivalent way that we can write these logarithms, or write these expressions in logarithmic form. So the next thing that we want to look at is we want to go the other way. We want to write each of these logarithms in exponential form. And this is actually the one that's a little bit more useful when you have really basic problems. So let's go ahead and do that. Our base here is 3, so that's the thing that's going to be raised to the exponent. Remember, this expression is just an exponent, and a happens to be our exponent. So 3 is our base. It's raised to the a power, and that's equal to the argument of the exponent, what's inside the exponent, or I'm sorry, the logarithm. So we have 3 to the a equals 27. So essentially this question is asking what power of 3 is 27. Or in other words, what's the exponent on 3 that gives us 27? Well, 3 to the first is 3, 3 squared is 9, and if we multiply 9 by another 3, we get 27, so that's 3 3's, and therefore we know that 3 to the third is equal to 27. This is an exponential form, and we can actually go forward with a little bit of logic and figure out that a is equal to 3, because we know 3 to the third equals 27. Same deal here, we've got a. That's what's being raised to the power. The power of that is 2. And that's equal to the argument of the logarithm, or what's inside the logarithm. So some number squared is equal to 9. Well, essentially we can solve this by taking the square root. And when you do that, you end up with a equals the square root of 9, which is plus or minus 3. All right, so from this, you can kind of see, this is our exponential form, but from this, you can kind of see that while it's not necessarily evident from the initial expression, if we just change it into an equivalent form, we can kind of reason our way through how to actually simplify and solve for that particular the particular variable that they're asking for. All right, so let's go ahead and move forward to property number 2. This is called the power property of logarithms. I tend to, or I guess I've heard this called the lasso rule, and it makes sense why it's called the lasso rule. So the property basically says if I have a log base anything, doesn't really matter what the base is, and doesn't really matter necessarily what the argument is, but it's raised, the argument is raised to a power. In this case, the power is a. I can basically take that exponent and move it to the front, and then evaluate a much easier logarithm. So essentially what I'm doing is the exponent becomes the coefficient, the number in front, and I'm now going to multiply that exponent by whatever the logarithm is, and it a lot of times will lead to much simpler problems. So this is called the power property. Anytime your argument is raised to a particular exponent, we can move that exponent to the front, make it the coefficient, and we can find a, or that power, times whatever the logarithm base b of the argument is. Let me show you a couple quick examples here. We want to simplify each of the following using that power property. So this right here, we've got an exponent on the argument. We can take that exponent and move it in front, and I can rewrite this as 5 times log base 5 of 25. So hopefully we can see now we started with kind of a difficult problem, a difficult logarithm that we're trying to figure out the exponent or simplify. And using that power property, we can move that thing in front, and now we have to evaluate this. Log base 5 of 25, a much easier log to evaluate. So when we bring this down, we know that this is equivalent to 5 times, and this is asking what exponent on 5 gives us 25. Well, 5 squared is 25, so the exponent is 2. So the log base 5 of 25 is 2. And to simplify even further, we know that 5 times 2 is 10, and that's our ultimate answer. One more quick example here. Again, we've got log base 3 of some argument, something, raised to a power. So using that power property, we can move that thing out front. That's going to be equivalent to 5 times log base 3 of 1/9. And now we can evaluate this log. This isn't necessarily a straightforward log. So let's think about this for a second. This is really asking what power of 3 is equal to 1/9. Well, if I rewrite 1/9 as 1 over 3 squared, hopefully you remember your properties of negative exponents. We know that if we raise 3 to the negative power, it's going to give me the reciprocal, 1 over 3 to whatever that power is. So this is going to simplify to negative 2. So 3 to the negative 2 power will give me 1 over 3 squared, or 1/9. So come down here and finish up what we started. We've got 5 times log base 3 of 1/9. We just figured out is negative 2. So 3 to the negative 2 gives me the argument inside. So 5 times negative 2 is going to give me negative 10. And we've just found an explicit answer for this thing that looked kind of ugly in the beginning using some of the properties of logs.